Okay. Okay. So yesterday we worked on the kind of the basic word problems for motion, right? Motion word problems. And you guys are all at 4 or better, it seems like, in your understanding of this, which is awesome. So now we're going to introduce one that's slightly more complicated. And it's a different equation setup at the end. We got to think about it. Before, our thing was, our scenario was, usually they were at the same place, right? They were right there, and they started at the same time, and they went in opposite directions. And this was the distance of one person, and this was the distance of the other person, and the total distance was the total distance, right? Total distance. So you ended up having d1 plus d2 equals this, right? Remember that? It was this plus this equals this bottom box. There's no bottom box now, okay? Because there's no total distance. Do you see that? If there was a total distance, it would go there. But there's no, in these problems, there's no total distance, okay?
Do we have to write
So,
the graph
so,
line?
so let's think about what our scenario is in this one. You don't have to write that down, but you should write this down. This is our scenario here is we have a place, right? And Tia leaves first, going in this direction, and she's going 51 miles per hour, right? And then 4 hours later, she's followed by Mira, meaning Mira is going the same direction, and she's trying to overtake Tia, right? Now, and she's going, what was it, 119 miles per hour. So clearly, Mira is going to overtake her, right? Don't you agree with me?
Yeah.
She's going to eventually catch up to Tia, because Tia is going
Double the speed.
so fast.
Tia, why do you have to
Beautiful
go so
little Toyota.
slow?
I mean,
Tia's going,
Volkswagen.
Mira's going
Right?
more than double.
You're right. That's more than double. Right. So it's going to be pretty fast. Now, would you agree with me that they do not leave at the same time? You agree with me? So times are no longer going to be the same. They're going to be different. And we have to take that into consideration, right? Now, but what do we know? When they are exactly, when Mira has overtaken Tia, they can both stop, right? Right? But what do we know though? What is the distance that by the time Mira overtakes Tia, how do the two distances relate to each other?
They're both in the same way.
Does that make sense? They actually both drove exactly the same distance. Does that make sense? Because even though they left at different times, one went faster. But they left at the same place, they started from exactly the same place, and then they ended exactly the same place, right? It's just that one started later, but the distance that Tia drove is exactly the same distance that Mira drove, right? So my formula, my equation, after I fill out my box, it's going to be this equals this. This distance equals this distance. They're the same. So I would say, if this is distance 1 and this is distance 2, I would say distance 1 is equal to distance 2. That's your formula now. That's your equation. Does it make sense?
Yeah.
There's no more, there's a total distance down here, right?
Wait, so we don't have to write the numbers in?
So we are going to have to write them in. We're going to write them in this box, but there's no longer this box
so we
down
can
here.
leave that
There's nothing that says they were total distance apart, right? That's not this scenario. That was this scenario, the total distance apart. So we had to add these two and equal that distance. Here, the distances are the same that they're driving. So we just make them equal to each other. So now we got to fill this in. Tia travels at the top speed of 51 miles per hour. Where would I put that?
51 mph.
Right here. All right, everybody gets that, right? Mira is going 119 miles an hour. And I have to just say, I'm really disappointed in you, Mira. The speed limit, my dear, they put those up for a reason.
Wait, she was driving on the
Okay.
German
And how are you
autobahn.
not in jail?
Oh, okay.
That's
All right.
okay, Luke is
Did
a
you
car.
like escape or
All right.
something?
Shh. Okay. Now we have to look at the time. This is the part that confuses people, and it's not that bad. But think about it. She is followed 4 hours later by Mira. Who started
Oh
later
my gosh,
driving?
I got it.
Who started?
I
Who
got it.
started driving later? Mira. So who drove the smallest amount of time? Mira. All right. If Mira left later, Mira drove the smallest amount of time. Does that make sense? Because she was going faster. She didn't have to go as many, as long. So let's make the smallest number Mira. The smallest number of hours Mira. Does that make sense? You get that? Well, I'm just going to use X this time. I could use T, but I already wrote it.
And then would Tia be
So-
X plus 4?
And then, yeah, wouldn't you agree with me that Tia, if Mira left 4 hours later, that means during those 4 hours that Mira didn't leave, Tia's still driving, right?
Right.
So Tia's time is Mira's time plus that initial 4 hours that she was driving. Does that make sense? So it'd be X plus 4 for Tia. You get that, guys? Fist of 5. I just want to know if you're really with me. Does that make sense? All right. Now, the rest is easy. Because look, this is just rate times time equals distance. So what goes here? This,
51.
parenthesis, right? X plus 4, right? And then 119x, right? And so what's my equation?
51x.
Will it
Plus-
always be the same speed? Like, will they always be at the same distance? Like in most
In these problems, when they're starting at the same place and overtaking, the
So it has to
distances,
mention, like,
it'll
overtaking.
always be this equals this.
Okay, so
Right.
it,
So I'm gonna write
What is it
51
equal?
x plus 4 is equal to 119x,
Oh,
right? You see that?
that's, I don't like that, Gary.
You don't like that?
I don't.
But this is the distance
like
T.
that.
But remember, this column, you gotta remember, you guys have to remember what these columns stand for. It's this last column usually that you're using, and that's the distance. This is the distance Tia actually traveled. This is the distance Mira actually traveled. And they're the same distance. So we set them equal to each other, and we use our distributive property. So we have 51x plus
X equals 3.
204, right? Am I right?
Yeah,
Is that right? Equals 119x.
and then you subtract.
And I'm going to subtract 51x, right, from both. And what does that give me on the right side?
Hold on, I'm doing that.
It's 60,
so that
68.
51 crosses
68x.
out.
68x.
Is that right? 68?
I don't know.
I'm trusting you guys. 60, oh, let's see. 9, 11, that's right. Okay, so then we're going to divide by 68.
That's 3.
Is it?
Yeah.
3 times 8 is 24. That sounds right. 3 times that is 18, 19, 20. Yeah, you're right. So x, I'm going to write it this way. X is equal to 3. So x is my time. So
That'd be a perfect country club.
Gary,
ringtone.
oh,
It's like a country club ringtone.
It's an awful
I'm sorry, in case it's,
Nasty.
I know.
in case it's an emergency or something.
That would be a perfect country
Yeah,
club.
it's right side there, right?
Okay, great. Good. Oh, I didn't.
would you
I
rather
didn't hang
it
up.
will take Mira 3 hours to overtake Tia?
So it would take. No wait. So wait. Now we have to quickly. Don't leave yet. We have to quickly read the final question.
It will take
It says, how
Mira
long
3
will it
hours
take
to
Mira?
overtake Tia.
It will take her 3 hours because Mira is X. That is one of the reasons it's also good to use the person that drove the smallest amount of time as the X, because when you solve for X, that's the answer. You know what I'm saying? If I had done X here and X minus 4 here, I would have then had to subtract 4 from it, right? All right, so I have the homework here.
Dang it, he remembered.
What? Oh,
He actually remembered today. Mira, don't leave.
usually when it's she was gonna leave and leave us rot.
Are we gonna like do like a new one then?
break my own word.